We've been spending a lot of time using Newton's laws, F equals ma, to find things like accelerations and stuff like that. So what I'm going to do is I'm actually going to take some of the basic stuff we've been working with and sort of like splice it together a little bit to sort of show a different type of quantity or a way to look at it. So we've been spending a good amount of time using, F equals ma to find things like accelerations, and of course accelerations change in v over change in t. And what I'm going to do is I'm actually going to put these two things together. So if I replace this with the delta v over delta t expression, I can actually write this as m change in v over change in t, something like this. Now what I'm going to do is, first of all, I'm going to multiply both sides by t, get rid of the t down here. If I multiply by t on this side, they'll cancel, or just move it over to this side. And I can rewrite that as force times change in t is equal to m times change in v. I'm just going to expand this out a little bit, and that'd be v2 minus v1. Okay, so you can find the change in v just by subtracting the two v's that you happen to have. And then what I'm going to do is I'm just going to multiply with these brackets. This is basic math. Multiply the brackets, and I'd have something like this. Now, I haven't really done anything new. I've just taken two of our old things and sort of put them together. And as soon as you do that, you can get this little expression right here, and that right there is momentum, which was worked on for you guys in grade 10 science. And that's what momentum is right there. Momentum is mass times v. Technically, lowercase p is the symbol for momentum, and it's mass times velocity, and that's how you find momentum. So momentum is actually just a combination of F equals ma and your basic acceleration expression. You put them together and you get momentum out of it. So not technically anything new, it's just a different way to look at it. So right here we have momentum, and right here we have momentum. So we're actually taking two momentums and we're actually subtracting them. So this would actually give you a change in momentum. And change in momentum, that is what is called impulse. So basic P equals mv is momentum, but if you have two momentums and you subtract them or add them or whatever, if it changes, that is what's called impulse. Now all of this is also equal to what we have over here, which is another really common way to find impulse. So there's two main ways people find impulse on a typical basis. One is to subtract two momentums, whatever they happen to be, and the other way you can do it is using force times delta t. So we sort of have two main expressions that are used. We've got momentum is equal to mv, and we've got a change in momentum is equal to force delta t, and this one is the impulse. So again, it seems like it's something new, but it actually isn't. It's just F equals ma and acceleration v over t sort of put together. Okay, so it's actually pretty simple. And it's basically what you can do is you can do a lot of the same types of questions you guys are doing before, just from a different perspective, using different quantities and stuff like that. But it's really the very similar types of questions. There's a couple things you can do better with momentum. Sometimes it's better to use F equals ma, VAT type stuff, but a lot of the questions can be done either way, and it doesn't really make much of a difference. All right, so let's sort of show you how this kind of works here. Okay, so here, let's bring in a picture of me in my car. So there you are, there's me in my car. And here, let's get some ground going over here. So there's the road, and there's me driving my car. So let's say my car, with me inside of it, of course, let's say is 2,400 kilograms, and let's say I'm moving at 15 meters per second. So let's just start with some basic quantities and basic ideas to see what's going on and how these different quantities sort of link in. So first things first, let's just find my momentum. Okay, momentum is m times v. I've got a mass, I've got a v, which means I can calculate how much momentum I have driving my car. As long as you're moving and you've got mass, you've got momentum. So if I do the 2,400 times the 15, I have about 36,000 for momentum. And the units for momentum are just a combination of the units of these two put together. Mass is in kilograms, and v is in meters per second. So it's really common to have kilogram meters per second for momentum. So there's another unit as well. Some people actually use the combination of the force and time, which would be newtons times seconds. So that's another unit that's often really common for momentum. Newton seconds or kilogram meters per second, it doesn't make any difference. It's the same thing. All right, so anyway, back to the question. So me and my car, I've got 36,000 kilogram meters per second of momentum. So let's change this a little bit. Suppose I speed up, because I am driving a Ferrari, and suppose I speed up to, let's say, 24 meters per second. Let's see what my new momentum would be. So the same type of thing. Momentum would be equal to m times v. Now this is a different momentum, so I'm going to use some subscripts. It's really common to use subscripts. This was my first momentum with my first speed. This can be my second momentum with my second speed. So I'll do the same type of calculation. I'll just take that 2400, that is the mass of me and my car, that hasn't changed, times that by 24, and I've got 57,600 kilogram meters per second for momentum. Okay, so what if I wanted to find out what's the impulse? Well, impulse is just change in momentum. That's all it is. Impulse is just change in momentum. So all I need to know is how much it changed by. Well, it went from 36,000 to 57,600. So all I have to do is just subtract the two to find out the change. And if I just subtract the two, it went and changed by around 21,600 kilogram meters per second. So that's my impulse. Okay, so it went from 36 grand to 57,600. It went up by 21,600. If it slowed down, the impulse would be negative. So positive impulse, you're going faster. Negative impulse, you are going to slower. So again, let's build on the situation a little bit more. Okay, what if, in my little Ferrari, maybe it took 4.5 seconds to go from 15 to 24? Well, then maybe what I could do is I could calculate how much force was used. Well, you could do, the change in v over change in t to get the acceleration. You could do F equals ma to get the force. Like, you can do it all that. You can do that, but you can also use impulse ideas. I know that my impulse was 21,600, and another way to find impulse, aside from subtracting two momentums, is to use this expression. So since I have the impulse and I have the time, I can just divide the two to find out what the force was. So force is just impulse divided by time. Well, I've got my impulse, that's the 21,600. I've got my 4.5 seconds. So if I just take that 21,600 and divide it by the 4.5, I've got a force of about 4,800 newtons. So 4,800 newtons was used to accelerate the car. So again, you could have done this question using F equals ma, the VAT, the two classic expressions we started with. This is just another way, another aspect to do similar questions by using an idea that you guys first learned about in grade 10 science when you guys learned about basic momentum. So again, nothing really new, just a different aspect or a different way to look at similar types of situations you guys have already been working on.